Section 4.3 is on Kramer's rule and determinants, which are always fun. Basically, what you have to start off knowing is that if you have this setup, which is a determinant, this means that you take R times U and you subtract from that S times T, or T times S, whichever way. So you take this one minus that one. That's just how they work. That's something you just need to know. There's no other way around it. So there's a rule called Kramer's rule where you can use second order determinants to solve equations. I'm not a big fan of this rule, but I think it's important for you to know how to do determinants because you're going to run into them later on. I never personally use this rule when I'm solving stuff unless I get into equations of like many equations with many unknowns. Determinants are very helpful because you can do it on a computer. So we're going to look at 3x plus 4y equaling 2. And we're also going to look at 5x minus 7y equaling 17. Now, the methods that you already know about, which would be substitution or adding and subtracting equations, they will definitely work for this. No question this will work. But we want to learn how to do this with second order determinants. Basically, you want to view this, we want to just be paying attention with second order determinants to the x coefficients, the y coefficients, and the answers. So you always have to make sure they're lined up this way. X's have to be in front, then your y's, then your constants. In this situation, the x and y combo forms the basis for the denominator of the answer. So we're going to have x equaling something, and we're also going to have y equaling something. For both of these, the denominator is exactly the same. We take the determinant of 3, 4, 5, negative 7. So we're taking this determinant for both of them. 3, 5, 4, negative 7. So I'm just taking this, writing it here, taking this, writing it here. Now remember, if we have, what do we use? RSTU, yeah. We have RSTU equaling RU minus TS, or ST, or whatever, doesn't matter. So I'm going to do the same thing here to get numbers. So I'm going to take negative 21 minus 20. That will give me a negative 41. So that's definitely going to be on the bottom of both of these. So I can keep this determinant here, or I could replace it with a negative 41. I'll do that on the y, but not on the x. Okay. Well, actually, I'll do it on the x too. So that's the denominator of my answer. Now we need to talk about the numerator. When I'm solving for x, I basically ignore those values and look at these two values. I'm going to put the y's where I would normally put them, but I'm going to put the answer in for where my x's were because I'm solving for x. Then I do the same thing. I do 2 times negative 7, which is negative 14, minus 17 times 4, which is 68, I think. Yeah, so that would give me a negative 82. So this is that value. And then I'll do the same thing with the y's. I ignore the fact that these are here. I put my x's where they would normally go, and I replace my y's with this answer over here. And then I do the same thing. 3 times 17, which is 51, minus 2 times 5, which is 10, would give me 41. Is that right? It is right. Okay. So what we would get is that x equals negative 82 over negative 41 would be negative 2. I'm sorry, positive 2. And y here would equal negative 1 because 41, if I replace this whole thing with 41, then that 41 over negative 41 equals negative 1, just like negative 82 over negative 41 equals positive 2. And so that's how you come up with your answers. It's the same process over and over. You just have to remember that the denominator is always x's, then y's, and then your numerator, if you're solving for x, you take your answer and put it where the x's were, and you make your matrix, or your determinant. If you're solving for y, you ignore your y's, you put these where your y's were, make the matrix. It sounds crazy. It's not used a lot, but you do need to be able to follow that formula and get these answers.